Balancing redox reaction using oxidation numbers. So the first thing we have to do is assign our oxidation numbers to all of the ions or atoms whose oxidation numbers change. So the first thing we have to do is examine who's going to change. So chlorine is going to change in this because oxygen, this is the perchlorate ion. Because it's perchlorate, it's not a peroxide, so oxygen is -2. Therefore, -2 times 4 is -8, plus something equals -1. So, do this down here. So, chlorine plus oxygen, and there's 4 of them, equals -1. So chlorine plus 4 times -2 is -8 equals -1. So chlorine is +7. Nitrogen dioxide. So this is not a peroxide, so the oxidation number of oxygen is -2. There's 2 of them, so a total negative oxidation number of -4. So nitrogen must be +4. And the math that shows that is nitrogen plus 2 oxygens equals 0, because this is a compound, so it has no charge. So therefore, nitrogen plus 2 times -2 equals 0. So 2 times -2 is -4, plus 4 plus -4 equals 0. Chlorine on the right here. Chlorine, this is an ion, so the charge on the ion is its oxidation number, so -1. And then we have to do the nitrates. So nitrogen plus 3 oxygens equals -1, the charge on the ion. So this is the nitrate ion, so the name specifies it's not a peroxide, so oxygen is -2, oxidation number of -2. So this is equal to -6. So nitrogen added to something that's -6 equals -1. Nitrogen must be +5. So there we have our oxidation numbers for this reaction. So I'm just going to erase all the work that I just showed you to make this a little bit tidier. So there we go. We have the oxidation numbers. So now we have to use the change in oxidation numbers and the formula subscripts to determine how many electrons are transferred. So what we're going to do is we have chlorine has a change here. The subscripts are both 1 on both sides. So we go from +7 to -1. So we gained 8 electrons, and there's a subscript of 1, so this is times 1. Then we're going to do it for nitrogen, the other one that changed. So nitrogen lost, because it went from +4 to +5, so you had an increase in oxidation number, and it only lost 1 electron, and the subscript on both is 1. So chlorine lost a total of 8, nitrogen lost a total of 1. So we have to now calculate the simplest whole number coefficients to balance the number of electrons transferred. Well, this one's kind of easy. What we do is we have to make the number of electrons transferred the same. So we have to make both of them 8. So we're going to multiply this by 8 so that we have 8 electrons. But that means whatever's connected here, the NO2 and the NO3, because we multiplied our electrons by 8, we have to multiply them also by 8 in the balanced chemical equation. Alright, so now we have to balance oxygen atoms and hydrogen atoms. So in order to balance the oxygen atoms, we're going to add water. And to balance the hydrogen atoms, we're going to add H+. So on the left-hand side, we've got 4 plus 16. So we've got 20 electrons on the left. Sorry, we've got 20 oxygen atoms. On the right-hand side, we've got 3 times 8, 16, 24. We've got 24 oxygen atoms. So we balance using water. So we're going to add 4 water molecules to the left-hand side. That will give us 4 extra oxygens. So now we've got 24 oxygen atoms. Now, there's 8 hydrogens now on the left, no on the right, so we have to balance by adding 8 hydrogen ions. So now we should be balanced. So we've got 4 H2Os, 1 perchlorate, 8 nitrogen dioxides, 1 chloride, 8 nitrates, and 8 hydrogen atoms. So on the left, 8 hydrogens, on the right, 8 hydrogens. Oxygen, 4, and 4 is 8, plus 8 times 2, 16. So we've got a total of 24 oxygens on the left, and we've got a total 8 times 3, 8, 16, 24 on the right. We've got 1 chlorine. We've got 1 chlorine on the left, 1 chlorine on the right. 8 nitrogens on the left, 8 nitrogens on the right. Now, with redox reactions, you balance for atoms, like normal, and we've just done that, but you also balance for charge. On the left-hand side, this has 0 charge, this has 1 negative, and this has 0. Add those 3 up, and we have a total of -1 on this side. On the right-hand side, it should equal that amount. 1 negative, 8 negatives, 8 positives. So these 2 will cancel charge, and we'll be left with 1 negative. So this is indeed a balanced chemical reaction. So this is balanced using oxidation numbers. Now we're going to balance using half reaction equations. So this is method B. And I've copied over because we know our oxidation numbers. So we can skip that step, but you have to do that. So the first step is to assign oxidation numbers and identify whose oxidation numbers change. Then what we're going to do is identify who's reduced, who's oxidized. And we're going to separate them into the half reactions. So chlorine and perchlorate gains 8 electrons. So gain is GR reduction. And that must mean that nitrogen losing, so it's oxidation. Leo, the lion says GR. So loss of electrons is oxidation. Gain of electrons is reduction. So now what we do is we put these into those two half reactions. So perchlorate will go to chlorine. So this is our oxidation. And then our reduction will be NO2 going to NO3. Okay, so we're going to balance these separately. So first of all, we're going to balance for atoms other than oxygen and hydrogen. So on the left-hand side, we've got one chlorine. On the right-hand side, we've got one chlorine. So we're balanced. Then what we're going to do is, like we did before, we're going to balance for oxygen with water. So we need 4 waters on this side. And then we're going to balance for hydrogens on this side with hydrogen ions. Now, we have to make both sides here electrically neutral. So right now, they're balanced in terms of atoms. What they aren't balanced in terms of electrons. So the right-hand side has a total charge of -1. So we want -1 on this side. If I add 8 electrons, this is going to have a net charge of -1. So now that is balanced for charge. Now we're going to do the exact same thing with the reduction half cell reaction. So nitrogen, there's 1 on the left, 1 on the right, so that's balanced. So now we're balancing for oxygen. 2 on the left, 3 on the right, so we need an extra 1 on the left. So we're going to add a water. That's an H, not an A. Okay. Now we're going to balance for hydrogen ions. I've got 2 on the left. I need 2 on the right, so I balance with H+. Now, I'm balanced for atoms, so now I have to balance for charge. On the left-hand side, we've got 2 compounds, so we've got a net charge of 0. On the right, we've got -1 and 2 times +1. So we need to add, that's a plus, we need to add an electron to this side. So now we've got 2 negative charges and 2 positive charges. So now what we need to do is make sure that the number of electrons is the same in both of these half cell reactions. So here it's 8, here it's 1, so I have to multiply everything in the second equation by 8 so that I end up with 8 electrons. So that makes this 16, this makes this 8, this is 8, and this is 8. So this is all to get the same number of electrons. And then what you do, it's like Hess's law, you add them together and you cancel anything that's on the left side and the right side of the arrows. So right away, our electrons will cancel. They're on both sides. Hydrogens, we've got 8 here, and we have 16 here. So this 8 will cancel and leave us 8 over here. Then waters, we have 4 waters on the right and 8 on the left. So what we will do is we will cancel these 4 and it'll take away 4 of those, leaving 4. So now add these two equations together and it should be your balanced chemical equation. So we've got ClO4 negative plus 4 waters plus 8 NO2s goes to 1 chloride, 8 nitrates, 8 hydrogen ions. So you would double check this. You would go through, make sure you have the same number of ions, the same number of atoms, and then that your charges are equal. So the left, total charge is -1. On the right, the total negative charge is -1 because the 8 nitrate negatives cancel with the 8 hydrogen positives. So this is how you balance a redox reaction using half-cell reactions. Both of these examples, it's the same example. Both of these methods are balanced in acidic solution. We know it's acidic because we have hydrogen ions, H plus, in our solution. So the question asked for us to balance in acidic solution, so we've added 8 H pluses. Now, rather we have H plus ions. If it said basic, you would add one extra step. You would add OH minuses to cancel your H plus. So let me just show you what that would look like. So if it said balance in base, what you could do is just add one extra step. I've got 8 H pluses, I want to cancel those and make it basic. So I would add to both sides 8 OH minuses. Now, H plus and OH minus make water, so we have 8 H2Os. They would be reduced by this 4, so we would have 4 H2Os. So if this was balanced in base, we would have perchlorate. Oh, that's bad writing. Perchlorate plus our 8 nitrogen dioxides plus 8 hydroxides. And this would go over here. We would have 1 chloride, 8 nitrates, and we would have a net 4 waters. So total charge on both sides, -9, because we have a -1 charge here and 8 -1s here, so that's -9. This is -1, 8 times -1, -9 total. And we're still balanced for our oxygens and our hydrogens. Oxygens on this side, there's 8 times 2, 16, plus another 8, 24, and 4 is 28. 8 times 3 is 24, plus 4 is 28. So you're going to get a different number of oxygen and hydrogens than balanced in acid, but it will still be balanced in the end. So that's how to balance a redox reaction of perchlorate ions, nitrogen dioxide, into chloride and nitrate in both acid and base.